Hi guys, again, this video is a continuation from video S011. We're continuing with the subject of wave energy. If you can remember on that video, I was using container wave energy generators. This is a new design, but it's the same sort of principle. Let's have a look in which ways it is different. So basically, I take a ship. And this ship here, I've cut away the bulkheads and there are no hatches on the ship so that we can actually see inside the ship. And it really is quite simple how this works. As you can see, we have containers resting on platforms, and the platforms are hanging from the top of the ship. And as the ship rolls, this platform will move from side to side, and as it moves from side to side, it will compress hydraulic oil. You can see it more clearly on this picture. Here are the containers sitting on the platform. The platform swings from side to side, and this ram contracts and expands, and it compresses oil, and the oil which is compressed gets sent to a hydraulic motor. Okay, so this is the diagram of the hydraulic system. Here are the hydraulic rams. They're the ones which are coloured yellow in the ship. And oil is here in the hydraulic ram and here in the hydraulic ram. So whether the hydraulic ram is moving this way or this way, it's compressing oil. These are one-way valves here, so the oil has to be compressed and sent to the hydraulic motor, and the hydraulic motor drives a shaft which drives a flywheel, and the flywheel drives a generator which makes electricity. That's basically it. Here's a reservoir to keep all the oil, and over here we have something called an accumulator where you can control the pressure of the oil, really. And it will help keep the pressure sort of constant. Here's a picture with the platform with the containers removed, just so you can see what sort of size it is. I've put a man here. The idea of this picture was to see what it would be like if I put beams to stop the platform swinging along the length of the ship, to stop it swinging longitudinally. I only want the platform to swing from side to side. So on this picture here, I only wanted it to swing towards you and away from you. I didn't want it to swing longitudinally. So this is the ship at anchor, and it has this anchor arrangement so that the waves will approach the ship from the side. If the waves approach from the side, the ship will roll a lot. Here we can see the anchors attached to the seabed. It's the anchor chain here and here. Here, tethered to this anchor here and floating up to the surface, floating on the surface, is a buoy. And here's the buoy here. Inside the buoy there's a wave sensor, and the wave sensor will measure the frequency of the waves and the distance between the waves. And this is important because there is a lot of weight hanging in the ship attached to a hydraulic system. By increasing or decreasing the pressure in the hydraulic system, it will be possible to control how quickly the ship rolls. And therefore it will be possible to synchronize the ship with the wave period. If you do this, you can make the ship roll a lot more. So now it's time to calculate how much power this generator will produce. I've actually called it a suspended containers generator because it's suspending containers up in the air. Okay, let's see how we go about calculating the amount of energy. The most important thing is the potential energy, and we measure the potential energy by working out how high we've lifted the containers. You've got to remember, actually the containers are staying stationary and the ship is sort of revolving around the containers. But if you were on the ship, it would look like that the containers are moving from side to side. So here is the weight here, right? And you can imagine this weight being the container. And it's swinging from side to side like this. Yeah. And when it swings to one side, of course, it gets higher off the bottom of the ship. So we know the weight of the containers, and now we can calculate the height, the distance which the container has risen because of the rolling. If we use that information, we can plug in, for example, how big the containers are, how heavy the containers are. I said that the ship, could be rolling at least 40 degrees from side to side. Probably sounds quite a lot, but as I said, if we can get the ship synchronized with the waves, we could really get it to roll a lot. Further down here, I have how long it takes the ship to complete one roll. And if I take all that into consideration, I could produce 10,000 kilowatts, which is 10 megawatts. So 10 megawatts, that's actually quite good compared to, for example, a wind turbine, which is 2 megawatts. Yeah. Oh, but did I mention though, I said that there would be 30 containers in the ship. So with 30 containers and the ship rolling 40 degrees, the maximum power I could get is somewhere around 10 megawatts. So, compared to a wind turbine, not too bad. Okay, a lot of people would say that 40 degrees is too much. And I could only achieve this 40 degrees here if the ship were to synchronize with the waves very well, and the waves were very constant too. So let's reduce that. Let's try and be a little bit more realistic here. So now the ship is rolling 20 degrees, and let's see how much energy that gives. Well, that's a lot less energy, isn't it? Now we're only producing a little bit more than a wind turbine at 2.6, 2.7 megawatts, much less. Okay, so perhaps the final problem I might have with this suspended containers generator is to catch the big waves. I'd need to put the ship far out to sea. For example, I was thinking of putting it about 500 miles south of Iceland or something like this, where the waves are very, very big. Now the problem with this is I don't know how to get the electricity ashore. How do I get the electricity to the land after I've produced it? So that's a problem. And I don't know how to overcome that. Maybe you have some ideas about that. We'll talk about that next time in class. See you next lesson. Bye.